Okay, for this problem, we have 8.1.5. 6 children were randomly assigned to read a story under ordinary conditions. 5 other children read versions of the same story, but with each child's own name substituted for one of the children in the story. The researcher kept a careful measure of how long it took each child to read the story. Using a 0.10 level of significance, does including the child's name make any difference? Completes parts A through C below. Okay, so, and in the instructor tip here, use StatCrunch. Be sure to select pooled variances for this particular problem. Generally, we stay out of the pool, and we do not pool variances. This particular one wants us to do that, but you would not know that unless I told you. So we're going to pool the variances. You get a slightly different result if you pool the variances. So we'll remember that when we do that. Okay, so part A. Let sample 1 be the ordinary story group. Sample 2 be the own name. So there we go. Ordinary is 1, own name 2. Determine the null and the research or alternative hypothesis. Fill in the blanks. The research hypothesis is that the population mean for the ordinary story group is, and here's where we look in the body of the problem, and it just says, does it make a difference? It never does speculate that one of the samples will have a less than or greater than. So we're just going to select is different from the population. So the null hypothesis is that the population mean for the ordinary story group is, and so we're going to say is the same as. So the null hypothesis has to contain the equals from. So we're going to say is equal to or the same as. So you can imagine this being the not equal to symbol and the null being the equal to symbol if we're going to be using symbols. Okay, now calculate the t-score. So I need to open up the data in StatCrunch. So click our little button here and open in StatCrunch. Okay, so we have 2 independent samples. So I'm going to go over here to Stat, T-Stats, and this is a 2 sample, and I actually have the raw data, so with data. Okay, and so we're going to say, so these are both reading time. This is probably the first one, but let me go back here, cancel out of this. Now you put maybe reading time for sample 1, reading time for sample 2, just to make sure. Or I could have put ordinary reading time and own story reading time. But I know what 1 and 2 mean, so let's go back and try this again. T-stat, 2 sample with data. Reading time 1, yep. Usually it is in the same, I think it's always in the same order that they appear if you happen at the same one. So pooled variances is going to be selected this time. Ordinarily we stay out of that. I'm not sure why this text decided to do that. Okay, so we're doing where we have equals for the null, same as, and not equal to for the alternative. And press compute. So here is our test statistic, t-stat, negative 1.699. And rounded to 2 places, that's going to be negative 1.70. Okay, now we want to determine the cutoff scores. So if we were going to graph this out, let me show you. I went back in and to this test and went ahead and selected the p-value plot. And it gives me this plot here. So we want to know where are those cut scores that I need to have in order for it to determine if it's significant or not. So this is one way to do it, and it's healthy to do a couple of these this way. So I'm going to get a couple ways to do it. We can use the table, and the table is actually not hard here. So click on the table, and what are we looking at here? We have a 0.1 level of significance, and our degrees of freedom are, what do we have here? We have 6 and 5 is 11, and then we have to take away 2. So the degrees of freedom, we basically subtract 1 for each one. And if you don't believe me, you can look back at your, here, so degrees of freedom, 9. So it'll give it to you here, 9, df is 9. So again, let's go ahead and go to stat, calculators, tstat. Actually, I'm not using that, I'm going to use the table first. I'll show you that calculator in just a second. So we have df of 9, and we are doing 0.10, right? Using the 0.1 level of significance. So we are at 1.833 would be our cut score. And we'd actually do both of them, right? Since it's two tails, we have negative 1.833 and positive 1.833. Let me show you how to do this on the technology. So there are a couple ways to do it. So you have degrees of freedom was at 9. And if I put in 0.1, and if I'm just doing the standard calculator, if it's 0.1, I'm dividing that by 2 because I have two different tails to split that between. And it's, again, negative 1.833. It's perfectly symmetric, so then the positive one will be positive 1.833. That's the way I do it. There is another way to do it. You could do the between one, so click between. I've got to redo this one and just put 0.1 doesn't work though, does it? So I have to do 0.9. And 0.9, because it's 90% of the data are in here, and then I've got 0.1% to split between the tails. Again, I still get the negative 1.833. Either way you do it is fine. I will never know which way you do it unless you tell me. So those are the two values. And we are rounding to 3 decimal places. Okay, put those in. Looks like we got it. And now we're going to reach a decision. So based on these cut scores, let's come over here. So those are my cut scores, negative 1.833 and 1.833. If we look at our t-statistic, does that t-statistic get into that critical region? No, it doesn't get in there. So it did not get to that region where I'm going to reject. So that's one way to think about it. The other way is to think about the p-value. So this p-value at 0.1234, it's in order, isn't it? 0.1234. So is that lower? Is it low enough? Because we did get a difference of about 3.5 here, right? So is that low enough to say this only occurred by chance? Well, it didn't beat our threshold. Our threshold was 0.1. Often when it's not a matter of huge significance, we will set that at 0.1. 0.1 is probably the highest I've seen these. And then 0.001 is probably the lowest you generally will see these. Unless you're doing like engineering airplane parts or something like that. So we failed to reject. It did not give us enough evidence to reject. So we fail to reject or do not reject. There is insufficient or not enough evidence that there's a difference between the means. So it wants us to sketch the distribution of the ordinary story group. And so we can use technology. This one's so small you could probably just do it by in your head. Is easy, but just in case it gives you a big one, we're going to go to graphs. We can do a histogram. And ordinary was the first one. We'll just take the defaults, see what that looks like. Looks like they kept the same bin width, so it's going to be slightly different, but it should have the same shape. Right, so we're going from flat shapes here all the way to a peak. Get out of the way. So the only one that matches that is this C version. All right. This one probably didn't need the technology to do that, right? You can kind of see we've got one that's in 3, one's in 5, one's in 6, and then there are 3 that are in 8. Okay. And then we do the same thing for the own name story group. So we can go back in technology if we need to, select the reading time number 2, which is what I renamed it, just so I wouldn't get confused later on. This one's a little confusing if you use technology, right? Because it bend it differently. So if you hover your mouse over the bins, you can see one item occurs between 4 and 6. And so each bin is actually contains a couple of numbers. So you can go back and adjust that. We can go to edit and change that bin width. Looks like they did it at 1. And so which one of those matches? You look at that right there. This one here, A. The only one that is that, right? I'll be honest, not a great, you only have 5 different observations here. Not sure how needed it was to do a histogram. Probably could have done a bar chart just as easily. Okay, now they want you to explain this to someone who's never had a stats class, but just understands a little bit. So our results do not support their theory that including the child's name makes a difference in their reading time. If I were going to add to that, I'd probably say that, maybe a bigger sample size might yield some different results, because we've got a very small sample size, 6 in one and 5 in the other, and that may just not be enough to know. Okay, so I hope that helps.